All right, hello everybody. Yeah, so 7.2, we looked at operation of decimals, basically, right? We looked at scientific notations, and we looked at rounding, and we looked at addition and subtraction, and the various mental uh, math computation processes, right? Now, for 7.3, we are going to be looking at repeating decimals, basically. Now, at the end of this section, um, students will be able to understand and explain why repeating decimals occur and how to tell if a decimal it will repeat. Now, how a fraction can be converted to a repeating decimal or vice versa, and ordering repeating decimals, right? And then we also look at um, this investigation. This is very interesting, the final bit of this section. And I will take you through a number of problems, a maximum of 4. I'll take you through 4 different problems and how you can change a decimal, a repeating decimal, to a fraction. Is that okay? It's a pretty short section. It's supposed to be at 13 slides, but the number of problems you'll go through will take us a little longer. Okay, so here we have examined decimal numbers such as that, all right? So these decimals stop, so we call them terminating decimals, right? On the other hand, we realize that there are some fractions or some decimals which do not terminate. We see some numbers repeating, right? And those are non-terminating decimals, all right? And we looked at how you'll be able to identify those. Now, a decimal of this type is a repeating decimal, and the repeating block of digits is the repeatant, right? So the repeating block of digits is what we call the repeatant. So usually in most books you see, so if you see this symbol, if you see this means that 1/8 repeats. In some books you see 0.18, and they put 2 dots on these numbers, meaning that these numbers what repeat. All right, nice. So here we are going to use our calc to change these numbers to decimals, right? And you realize that all these numbers repeat. 1, 4, 2, 8, 5, 7, they repeat right there. And these are what? Repeating. Okay, nice. So here we want to write 0.5 repeating as a rational number in the form a over b. So first, you let x be equal to the decimal 0.5 repeating, all right? Now, the second step is to multiply both sides of the equation by 10. And you multiply by 10 because there is a single repeating decimal, right? There's a single repeating number. So since there's one digit that repeats, which is 5, that is why you are multiplying by 10. So you multiply that equation by 10, and that gives you that. So you have 10x being equal to 5.555 repeating, right? I'll take you through a number of problems on this. Okay, so let's just go through the steps. Now subtract the expression in step 1 from the final expression in step 2. And that gives you what? 9x being equal to 5. Now you want x, so you divide both sides by what? By 9. So that repeating, the fraction that gave us the repeating decimal is actually 5 over 9. Okay, and that is your answer. So we needed the fraction that gave us the repeating decimal. Okay, and that answer is 5 out of 9. Okay, nice. Now, there's another alternative way to do this. All right, and it works out the same. It works out perfectly, and you get the same results. Okay, nice. Now, in general, if the repeating is immediately to the right of the decimal point, first multiply by 10 to the m, where m is the number of digits in the repeatant, and then continue as in the preceding cases. Is that okay? And I'll let you know what this is all about. We are going to look at an example like that, okay? Now, suppose the repeating block does not occur immediately after the decimal point. A strategy for solving this problem is to change it to a related problem we know how to solve. That is, change it to a problem where the repeating block immediately follows the decimal point. All right, again, we are going to look at examples how this really works. So for instance, you realize that the repeating decimal does not come immediately after the decimal point, and that is what you see here is talking about. Is that okay? So first, you have to move the decimal point closer to the repeating block of numbers. So by doing that, you have to multiply by 10 first, all right? And then you have to multiply by 100 again because the repeating block is 2 digits away. Is that okay? You do the operation, and finally, the fraction you are looking for is 129 over 55. We are going to do some examples, but this is just an introduction, okay, to what to expect. Now, this is a surprising result. We have 0.9 repeating, and we want to look for that fraction, and we came out after we did the operations, realized that this is what actually 1. This is surprising, right? But it happens. Very unique case. Now, ordering repeating decimals. So if you want to order repeating decimals, what do you do? You have to lay these decimals side by side and compare the digits. Is that okay? And that will let you know which decimal is bigger than the other. Okay, and you'll be able to assign a greater than or a less than to the numbers involved. Okay, good. So basically, that is how you order repeating decimals. And this is just the 13th slide. Now, so really, that should be the end of this section. But let's go. Let me share a whiteboard with you, and then we go to look at some examples of how to deal with problems like this. Okay, so let's see. So I have some numbers. So I have some. So we want to find. So I have 4 examples for us to go through. Find a rational number in the simplified form A over B. So we want to find. So the question is find a rational number in the simplified form A over B. So typically we are looking for a fraction of repeating decimals. So the first problem we want to look at the fraction for 0.4 repeating. Now 4 repeats, is that okay? So 4 is a repeatant. Now what we do here, we start by saying that let x be equal to 0.4 repeating. Now because there's 1 repeating number after a decimal point, so we will say let this be equation number 1. We are going to multiply equation number 1 by 10. And if we do equation number 1 multiplied by 10, we're going to have 10x. That will transform into 10x being equal to what? If you multiply this by 10, this will give us 4.4, and the 4 still repeats right there. And this is our equation number 2. Okay. Now, the process is that we are now going to do equation number 2. We will take away equation number 1. So we have 10x, okay, being equal to 4.4 repeating minus x, okay, which is equal to 0.4 repeating. So we do the subtraction. And what do we have? If you do this subtraction, this is going to give you 9x right there. And this gives you 4. Now you divide both sides by 9. And your answer is 4 out of 9. So if you do 4 over 9, it will give you 0.444444. So that the fraction that gave us this number is 4 over 9. And that is how you go about it. Gucci? Sounds good? All right. Let's look at another example. We are going to do 4 different examples. Okay. Now the B part, we have the decimal 0.61 repeating. So here we have 2 numbers that are repeating, right? So we will let our X be equal to 0.61 repeating. Okay. Gucci. Now, because there are 2 repeating numbers right after the decimal point, we are going to, so we will let this be equation 1 and multiply equation number 1 by what? By 100, because there are 2 repeating decimals after the decimal point, numbers after the decimal point. So we multiply straight up by 100. So if there were 3 repeating decimals right after the decimal point, there were 3 repeating decimal numbers, okay, or there were 3 repeating numbers after the decimal point, we're going to multiply by 1,000. Okay, now, so we have 1 multiplying by 100. So the equation now transforms into what? 100x is equal to 61.61161 repeating, and this is equation number 2. Okay, so now you do 2 minus 1. Okay, so really, let me rewrite that. So you do equation number 2 minus equation number 1. You find a difference, and this will be 100x is equal to 61.61 repeating, and then you have x 0.61 repeating. You subtract. Now that should give you 99. 99x is equal to 61, and you divide by 99, and your x is now 61 over 99. So that is the repeating, that's the fraction that gave you the repeating decimal 0.6161 repeating. Okay, so you are looking for the fraction basically that gave you that, and if you put that in your calc, you get that answer. Sounds good? All right, now let's take the next problem. Okay, so basically before we do that, you have to make sure that the repeatant, okay, the number that repeats comes immediately after the decimal point, and that is what we went through with the lecture. Now let's take another example. So the C part of this problem is that we have 0.29, and this time it's 9 that repeats. Okay, so here we will let our x be equal to 0.2, and 9 is the repeatant. Is that okay? Now we have to get the decimal point closer to the repeatant. So how many numbers come before the repeatant? Just a single number. Is that okay? So here we are going to, now this is equation number 1. We are going to first of all multiply equation number 1 by 10. Okay, just to get the decimal point closer to the repeatant. Let me clear that and rewrite it. Okay, nice. So we multiply by 10 first. Now when you multiply by 10, this will transform into 10x is equal to 2.9 repeating. Okay, so now you realize that this looks like the original problems we had earlier. So if you go back onto problems A and B, this looks like the problems we looked at for A and B, right? So now this becomes your equation number 2. So now you have to move the decimal over the repeating. So there's a single number after the decimal point. The repeatant is 1. So we are going to again multiply equation number 2 by 10. Okay. So by doing equation number 2 by 10, this becomes 100x is equal to 29.9 repeating. Now we have 3 equations. Now we can deal with these 2 equations, just like we did for A and B. Okay, so now we do 3 minus 2. Okay, let me go here and do the subtraction. So we have 100x being equal to 29.9 repeating minus 10x is equal to 2.9 repeating. Now we subtract these 2 and we have what? 90x being equal to 27. Okay, now we divide both sides by 90 and our fraction, the fraction we've been looking for, if you reduce that, this will be 3 out of what? 3 out of 10. And that's the fraction we've been looking for. Is that okay? Good. So that is for C. Is that okay? So note closely how you go about this. So your first goal will be to move the decimal point to come, okay, before the repeatant, the number that, the digit that repeats, okay? So if there were 2 numbers before the repeatant, you are going to multiply by 100 just to get the number closer, right? And then you think of moving the decimal point over the first repeatant. Is that okay? So, and then you subtract. Nice. So let's go back. Let's go and look at the last problem that I want us to look at under this. So D, we have 2.029 repeating. Is that okay? Now we let x be equal to the same number. So that is equation number 1. Now we want to get the decimal point closer to the repeatant, right? So the repeatant is 29. So now we have to multiply by what? 10. So we have to do equation number 1 multiplied by 10. So we have 10x being equal to 20.29 repeating. So we have equation number 2. Okay. Now we have to move the decimal point over the repeatant, right? So there are 2 numbers that repeat. So we have to multiply 2 by what? 100. And if you multiply 2 by 100, okay, this becomes what? 1000x being equal to 2029.29 repeating. So we have 3 right there. Now I can deal with these 2 equations at the same time. Is that okay? So now I will do equation number 3 minus equation number 2. Okay. And I'll do that towards my right. So I have 1000x is equal to 2029.29 repeating. Okay, minus equation number 2, which is 10x. Okay, so really equals 20.29 repeating. I subtract the 2. Okay, and what do I have? I have 990x being equal to 2009. I'll divide both sides by 990. Divide by what? 990. And I have my x being equal to 2009 over 990. And that's my answer. Is that okay? So basically, this is how you deal with problems like this. So changing repeating decimals to fractions, okay? And that's how this goes. So thank you very much for your time, and let me know if you have any questions on this. Okay, so thank you so much, and do have a good day. Bye.